So now we want to factor again. And remember, when you factor, you rewrite the expression into one term. You should have only one term in your answer with lots of factors, and it needs to be an equivalent expression. So I'm going to try to get 4 examples in. Suppose you're asked to factor 2x squared plus 17x plus 21. Okay. All right. Now, first step. You're going to learn, maybe if you continue with algebra, lots of different techniques for factoring, but you always look for a GCF and take that out if there is one. So, is there a number that divides into 2, 17, and 21? Nope. Is there an x common to every term? Nope. There's no GCF. Sometimes there's a GCF, sometimes there's not. Then the other thing, I mean, as you learn other methods, you might be seeing some different things, but from our previous videos, we should notice what I'm looking at. You see that quadratic term? You see that linear term? You know, the quadratic is the squared term, the linear is degree 1. You see that constant? This is a typical answer to a FOIL problem. So maybe this came from foiling something. Well, if I foiled something, that means my multiplication problem was a binomial times a binomial. Okay, so that's my anticipation. So I'm going to help myself structure my thinking by opening up 2 parentheses ready to write out a binomial times a binomial. And I'm going to fill in the parentheses everything I know for certain. Like for instance, all these signs are positive. These have to be plus signs. No other option. Now, I'm going to remember, you know, the quadratic term always comes from first times the first. That's how we get that term. So I'm going to think about it. Well, whatever goes here and here has to be multiplied out to be 2x squared. There's no options. That has to be 2x and x. It won't matter if you write x and 2x. You know, x here, the 2x there. The multiplication is commutative. All right, so I got it going. Now the next thing I'm going to remember is that last times the last, that's how I get the 21. Now, I'm not real sure because there are a couple options here, so I'm going to look at these. Last times the last, 2 numbers that multiply to 21 could be 21 times 1, or it could be 7 times 3. Okay? Now, at this point in time, it's an educated guess. Is it the 7 and the 3, and where do they go? Is it the 21 and 1? Well, we know the 17 is outer plus inner, and everything's positive, and I'm just thinking if I put that 21 in, the middle term's going to be bigger than 21. I just don't think it's 21 and 1. So I'm going to guess 7 and 3. And I'm just going to randomly guess that the 7's going to go here and the 3 is going to go here. Now I check. Think about it though. The check can be pretty fast. You know you've got the quadratic term. You know that's 2x squared because that's why you picked the 2x and the x. You know you've got the constant. That's supposed to be a q, if you were wondering what that was. You know, and that's a check, that's good. You know you've got the constant 3 times 7, that's the 21. What you don't know is if you multiply this out, will you get the 17x? Well, that 17 comes from outer plus inner. So the only thing you really need to check is what is the outer plus inner? Well, the outer here is 6x. The inner is plus 7x. So that's 13x. I need it to be 17x. No good. Well, don't abandon the 7 and the 3 yet. Try again. It makes a difference because this is 2x and 1x. It makes a difference where you put the 3 and where you put the 7. So I'm going to try 2x plus 3, x plus 7. So I'm switching the positions of the 3 and 7. And again, I know I got the quadratic term right. I know I got the constant right. I just don't know about the middle term. So, and that comes from outer plus inner. So the outer is 14x here, and the inner is 3x here, and that's 17x. Bingo. This is the answer. So my original expression factors into this. Notice my answer is one term. With two binomial factors. And if you recall the other video, this is actually one of the ones that we multiplied out. Not every example I do is going to be ones that we multiplied out. So let's try this one. We're going to factor 2x squared plus 9x minus 18. Okay. Always look for a GCF. Nothing divides into 2, 9, and 18. X is not common. No GCF. Start recognizing. Does this possibly come from FOIL? Oh, quadratic, linear, constant, maybe. So if it did come from FOIL, that means you multiplied two binomials. A mistake students make is just try to figure this all in your head. I don't do that. And I've been doing this probably longer than you've been alive. I write things down to frame my thinking. First, I open two sets of blank parentheses for the binomial times the binomial. Then I'm going to fill in anything I know for certain, because there's definitely some guesswork in this. I know that whatever goes here and here has to multiply out to be 2x squared. So again, it's got to be 2x and x. Now, signs, the other one was all plus and plus, but what I know is that last term was negative. See, the constant's negative? And if we recall, that was negative because I multiplied a negative times a positive. So one of the signs is negative, one's positive, but I don't know which one. I'm going to hold off on that thought. The other thing I'm going to think about, okay, whatever goes here and here, last times the last, that has to multiply out to be 18. And there are options there. So I'm going to list the options for last times the last. There's always 1 times 18. Let's see, there's 2 times 9, and there's 6 times 3. You just got to guess. Now, there is something that I can show you that will help you guess. Let's do a very bad guess, and what you want to do is avoid bad guesses. Let's guess the 2 and 9, and let's put the plus 2 here, and let's just randomly make this minus 9 for now. Okay. This cannot be right. Look at this factor. Isn't there a GCF of 2? Well, if this factor has a GCF of 2, you can write that as 2 times x plus 1. That means there was a GCF of 2 up here that I overlooked. But I did not overlook a GCF. This is impossible. So one of the really good lessons to learn is to, when you're creating your factors, don't create GCFs within your factor. Unless you forgot to take out the GCF, there won't be one. So that's no good. Now, we could switch the positions and put the 9 here and the 2 here. And then you could randomly put signs if you want. I'm going to show a different way to deal with that. So what I know is I got the quadratic term. I know that's 2x squared. I know this is minus 18. What I don't know is did I get 9x in the middle. So outer is minus 4x Inner is plus 9x. That's 5x, no go. So the 9 and 2 are out. Okay. We got more options. I'm not really feeling the 1 and the 18 again, just because the middle term, if there was an 18 of a multiplier, this should be bigger. I'm going with the 6 and the 3. Okay, so I'm going to try the 6 and the 3 next. And by the same thought, I cannot put the 6 here. If I put the 6 here, there'll be a GCF, but there is no GCF. So I'm going to stick the 6 here. I'm going to put the 3 here. Now, this is what I usually do for signs. I know there's one plus and one minus. So what I often will do is I'll say, well, what's the outer? Well, the outer is all right, did I mess this up? Oh no, all right. The outer is 12x. It's just late at night. The inner is 3x. I know one's plus and one's minus. When you add signs where one's plus and one's minus, you actually subtract their values. So 12 minus 3, does that subtract a 9? Oh, yes it does. And I want it to subtract a positive 9, so I need the 12 to be positive and the 3 to be negative. So I go back and say, well, I need to put the plus here to make the 12 positive, and I need to put the minus there to make the 3 negative. And then if you check this, if you FOIL this out, and the thing is, you can always check your factoring. I don't always do it because of time, because I'm checking along the way, but if you wanted to FOIL this back out, this is 2x squared, outer is plus 12x, inner is minus 3x, last is minus 18, 2x squared plus 9x minus 18, that's what we started with. There it is. That's the factorization. This is all one term with 2 prime factors. So probably just going to do one more problem. So I changed my mind about what I do, so I have to think about the problem here. All right, so we are going to be looking at this next problem. Sorry for the delay. We are going to factor. Okay, and hopefully I get this straight. 12m cubed, okay, minus 10m squared minus 2m. Okay, so notice this is not in factored form because there are 3 separate terms. You're not in factored form unless you're all one term. First step to factoring is looking for GCF. Oh, wait. Every coefficient is even. Ah, there's a GCF. 2 divides into all those. And oh, there's an m common to all these terms. So there is a GCF. So I need to factor out the GCF. Now remember, that's a different process than reversing FOIL. The GCF is a monomial times 1 big fat parentheses. And if there are 3 terms here, there better be 3 terms in this parentheses. So 2m times what gives you 12m cubed? Oh, that would be 6m squared. 2m times what would give you minus 10m squared back? Oh, that's minus 5m. And then a lot of people will say, oh, I don't need the 2m's not. 2m times nothing doesn't give you anything. So 2m times what gives you negative 2m? Oh, that should be positive 2m. When I wrote that, that's supposed to be positive. That would be plus 1. I copied that down wrong. So you need that 1 there, otherwise when you distribute, you will never get that 2m back. Okay, when you factor, this is one thing I haven't talked about yet, all factors must be prime. And so you look at this and you go, ooh, wait a minute, that's a quadratic term? That's a linear term. That's a constant. Maybe this came from FOIL. Maybe I could factor this some more. So I should try. Now the 2m, you just carry it down. And then if it's from FOIL, it's a binomial times a binomial. Okay? You're going to write in as much as you know for certain. Now this time, first time's the first. I don't really know it for certain. This hasn't happened before, but to get that 6m squared, it could be 2 times 3 or 6 times 1. Don't know. Okay. But last time's the last. To get 1, that has to be 1 and a 1. There's nothing else. There's one other thing you know. You know the signs. See how the last term is positive, but the middle term's negative? Of course, the quadratic term's also positive. There's no way you can get a negative middle term if these are all positive. But if this is positive, it has to be the same sign, so they both have to be negatives. All right. Now, since they're both negatives, I know my outer plus inner will both be negatives. It'll be a negative number plus a negative number, which means I'm going to add their values. They're going to be net losses. So I'm looking at the 2 and the 3, and I'm looking at the 6 and the 1. 2 and 3 actually add to 5. So I'm going to try the 2m and the 3m. And then I'm going to check. My outer is minus 2m. My inner is minus 3m. And sure enough, that's minus 5m. So I did that part right. This is the final answer. So notice my factored answer is all one term with 3 different factors. And just on a note here, I want to do a little compare and contrast. What if I'd ask you to factor 6m squared minus 5m minus 1? What's the difference? One little sign change. Okay, well, all right, this looks like it's a FOIL problem. There's no GCF. I know it's a 1 and a 1. This time, it's a plus and a minus. And since they're both 1s, you can just put those in kind of randomly. First times the first is still that option of 6 times 1 or 3 times 2. But this time, the outer and inner will have opposite signs. It'll be a negative number plus a positive number. And when you do that, you actually subtract their values. So I would need the outer and inner to subtract to 5. Well, 3 and 2 won't subtract to 5, but 6 and 1 will. And I need the 6 to be negative. So if I put the 6m here and the 1m there, outer is minus 6m, inner is plus 1m, adds up to negative 5m for the middle term. That's what I wanted. So here's the correct factorization. So notice how that one little sign change changed the factors quite a bit. All right.